right, we're back. We're looking at basic statistics. This is chapter 3, and let's take a look, shall we, at percentiles. So percentiles are where you are, where your score falls amongst a group, amongst a class. Ooh, you know what? So we don't have to hear that. All right, so let's jump into percentiles. It's page, where are we here? Page 11 on the note packet 3. So on the top of the page it says percentiles, page 11. And so first we put them in order. So I already put them in order. And so now they want to know, where amongst the group do you fall if you were 60 inches tall? So there's 15 heights here, 15 heights. And if you were 60 inches, let's circle that, you would be right here. And so for percentile, all you do is you count how many people you're ahead of. How many people did you beat? 1, 2, 3. So you beat 3. You always add 0.5 to it. That's a constant. So it's however many pieces of data are below plus 0.5 divided by the total number of pieces of data, which is 15. So we do 3.5 divided by 15. You click that into your calculator, you get 0.233333, or that's about the 23rd percentile. All right. What if they go the other way? What if they say, how tall do you have to be in the 70th percentile out of this sample? So how the 70th percentile, what we do is we say, okay, well then let's take 15. So find the height that goes with the 70th percentile. So what we're going to do is we're going to take 0.70, we're going to multiply that by 15. That is 10.5. And so no matter what, even if it was 10.1, even if it was 10.2, you take it up to the next integer, the next whole number. So that's the 11th. So you would have to, basically, you would be in the 11th position. 70 would be in the 11th position. So we'll say percentile sub 70. That's what that little sub isn't like a power where it actually does something. It just means I want to use percentile, but I want to attach some value to it. So I want to use P again. So P sub 70 just means that's a value. It isn't, this doesn't have any mathematical, it's not like square root or square or anything like that. All right, so P sub 70, the 70th percentile is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should have beaten 10 people, basically, and you would be in the 11th position. Oh, so coincidentally, it ends up being 70 inches. It really, there's no connection there that the 70th percentile just happened to match with this 70 inches in the data. All right? So note, if it worked out to be exactly 10 or exactly, let's say this, we did all this and it worked out to be exactly 12. All right, so we get an exact number 12. You can't just count to 12 because it's got to beat 12 people basically. And so instead of going to like here, we would actually say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we'd also look at the 13th and we'd average those two together. So if it works out to be a whole number, when you multiply the percent by the number of pieces of data, average that one and the one above it, and that'll be your answer for the position, the number for the percentile. All right, next we're going to talk about quartiles. Quartiles are pretty easy too. We're going to use the same chart here. I'll erase. We'll rewrite the 60 and we'll rewrite the 70. Okay, so when we talk about quartiles, what we're talking about is the median of the lower half and the median of the upper half. And so it's as long as the data is in order, so you put the data in order first, you find the median. There's 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th piece of data, and that means there's 7 below it, and 1, 2, 3, 4, 5, 6, 7 above it. So now when I find quartiles, so that's the median, and the median is also known as the second quartile, Q sub 2. A lot of times we just say Q2. So Q2 is 66, or the median. So now, hold that out, don't even look at that. We're only looking at 1, 2, 3, 4, 5, 6, 7, these 7 pieces of data. And so now we want the middle of that. So just forget about that, pretend that doesn't exist. We just want the middle of this set. So 1, 2, 3, 4th piece of data here is going to be in the middle because that's 3 below it and 3 above it. So Q1, the first quartile, is 60. Q2 is 66. Q3, 1, 2, 3, 4, 5, 6, 7. So the 4th piece of data, the one right in the middle, 71. So that's called the upper quartile, the median, and the lower quartile. But all you're really doing is finding the median 3 times. You find the actual median, you separate the data into 2 halves, and you find the median of the lower half and the median of the upper half. And what we've done now by circling these numbers, look, we've broken it into quarters. There's the lowest quarter, there's the second quarter, third quarter, fourth quarter. And all together is all of, right, all 100%. All right? So off of those, you can do what's called a box and whisker plot, or a box plot. And those look like little lines and little squares and boxes. Let's see, are we doing it for this data? We are doing it for that data. So we'll go into how to find an outlier, but first let me make a box plot, and then we'll do a modified box plot also. So here, let's get rid of this part. I'm going to leave this data up on the board, but we're going to get rid of the percentile stuff, all right? So on the next page, we're using the same data, and they want us to find outliers. And so an outlier is a piece of data that doesn't fit, but you know, how much doesn't it fit? You could say, well, 89 doesn't fit. It's a lot higher than 77, but how, is it too high? Is it an actual mathematical outlier, or is it just kind of doesn't quite fit with the rest of the data? And so there's actually a method of finding whether it is a true outlier or not. And so it works by using the interquartile range. So here, let's find the IQR. What you're doing to find the IQR is you're just subtracting the third quartile minus the first quartile. And that's the middle 50%, if you think about it, right? You can see it right here broken up. So that's the middle 50%. So we've got 71 minus 60 is 11. So the IQR is 11. Now, what we do with that IQR to identify outliers, for a high outlier, so an outlier on the top end, you take the third quartile and you add 1.5 times the IQR to it. So we take 1.5 times 11, and then we add that on to 71. So 71 plus, what is 1.5 times 11? 11. Half of 11 is 5.5. Add it back on, it's 16.5. So that's no longer the IQR. That's 1.5 times the IQR. You add it to the upper quartile, and that is the threshold. So if it is above 87.5, it is a mathematical outlier. That's the boundary on that top end. Now, this one only went up to 77, but that one that I just made up, I said, oh, 89, that's kind of out there. That would have been an actual outlier. 83 would not. 86 would not. Heck, 87 would not be an actual outlier. But 87.5, anything above that is an outlier on the high end. For the low end, we take Q1, so low end outlier. We take Q1 and we subtract 1.5 times the IQR again. And so that's going to obviously be the same. We got 60 minus 16.5. And so that's 43.5. So anything lower than 43.5 is considered a mathematical outlier on the low end. And lo and behold, look at that. 37 is below 43.5. So this is an outlier. All right, 55 is not. So in this data, 37 would be a low outlier because it is less than 43.5. Okay, so now it says make a box plot. So I'm going to do actually two pictures for you here. We'll make a box and whisker plot or a box plot, but then we'll also do what's called a modified box plot, and we'll talk about whether it's skewed or not skewed. All right, so I'm going to erase this stuff. We know 37 is an outlier, so I'm getting rid of the work here, but I'm going to keep this up there because they want me to make a box plot based on that data. And so standard normal curves are symmetric. That bell-shaped curve is in symmetry to it. Skewed curves are non-symmetric. And so you can kind of get the idea of a shape using a 5-number summary. This 5-number summary is this. It's the lowest value first. So the minimum here was 37. The lower quartile is 60. The median or middle quartile is 66, second quartile. Third quartile or upper quartile is 71. And then the maximum, the highest value, is 77. Now this is very important. This part is very important. This is the number one mistake I've seen over my many years of teaching math, is people don't put a uniform values down here. They always make it symmetric. Don't do that. First, let's go, it goes from 37 to 77. So before we start anything, let's make a uniform little set here. 30, 40, 50, 60, 70, 80. Okay, so that's all nice and uniform. And then let's put in our values. So we got 37 is the low end, so it should be somewhere around there. Again, if you want to cheat it a little bit and put the actual values, you can put it above, but you don't have to. That's not a requirement. Then 60 gets a line. Then 66 gets a line. 71 gets a line. And 77 gets a dot. And then you connect that into a box. So look, this is the IQR from there to there. That's 11. And then these, it used to be called a box and whisker. I guess that was too silly, so they just renamed it a box plot. But box and whiskers, right? There's the box, there's the little whiskers. This is not a symmetric graph because look, we've got all of this heavy on the low end. This is skewed to the left. If we were describing the data on this, we would say skewed left. All right, and that's a regular box plot. But now, we identified this as an outlier. So we have what's called a modified box plot. And what you do with that is any outlier doesn't get connected to this line. So what we do, it looks almost identical. 30, 40, 50, 60, 70, 80. So I do that first. So I have uniformity down there. And then instead of starting with the 37, that's an outlier, so we actually hold that out. We start with the 55, and then we put in all the rest of our data. So 60 and 66 and 71 and 77. And now look, that looks a little more, and now for the modification, here comes the modification. You put a dot there because that one was an outlier. But now look, if I pull that outlier out of the data, this looks pretty close to symmetric, where with the outlier in there, it's clearly skewed. And so this is called a modified box plot. All you're doing with a modified box plot, if you ever see one, it looks identical, right? They're both box plots, and that's still the IQR and lower quartile, median, and upper quartile, highest value. This is the lowest non-outlier value. This is just the lowest value in the set, whether it's an outlier or not. All right? So you could see multiple dots. There could be multiple outliers. There could have been another smaller one or a really big one over there. And if we didn't do a modified box plot, you would just connect it, and that would be it. All right. So that, what can we say about the height? This is all on heights, that it's skewed left or negatively skewed. We'll say skewed to the left. All right. And then the last one, they want you to put 2 box plots down with the data. So you have to put it in order. Here, I'll work those 2 out also. Let's get these done. So we're on the last page, page 13 of the note packet. It has fake cheese and real cheese. And I think they're talking about the sodium content. Is that what's going on there? Quick comparison. Suppose we compare, yeah, sodium content. So like how much salt is in fake cheese and how much salt is in real cheese. And so when we do this, we can do real, fake, or artificial if you want to be fancy. All right, and we're going to find the minimum, the lower quartile, the upper quartile, the median, the upper quartile, and the maximum for both. All right, so first we have to put it in order. So let's order the first one. Is 40, 45, 180, 190, 220, 240. What do we got there? 310 and 420? 310 and 420. So there's 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that means it's an even set. So we're going to take this 1, 2, 3, 4, and 1, 2, 3, 4. So the median isn't in the set. The last one, there was an odd number, there's 15. So the median happened to be one of the numbers in the set. This is an even set, so the median isn't included. So we're going to take 190 plus 220 and average that out, divide it by 2. And that's going to give us, what is that, 215? Which one is this? This is the real cheese. No, that's going to give us 112.5. No, it's going to give us 215. Right. One 90 plus. Oh, wait. I put down 190. No, that's the correct data. Where did I do that? 190 plus 220 for the real. Oh, 205. Jeez. I don't know why that took me so long. Sorry about that. Just a brain freeze. All right, so that's the median. The real has a median of 205. And then the fake, we'd have to do the same thing. We'd put them in order. I'm almost scared now to put them in order. We got, what's the order here? 130, 180, 250, 260, 270, 290, 310, and 340. And so for the fake, there's also just 8 pieces of data. So 1, 2, 3, 1, 2, 3, 4. So between 260 and 270, that one we could do in our head, right? 265. You'd add 260 plus 270 and divide it by 2. Remember, if you're putting this in your calculator, hit 260 plus 270, hit enter, and then divide by 2. That'll be 265 for the real. All right, so now for the lower quartile, there's only 1, 2, 3, 4 in the lower half. And so we find the average of those two middle numbers. That's 45 plus 180 divided by 2. That's the 112.5. The minimum here was 40. The upper is between 240 and 310. So you're adding 240 plus 310 and then dividing that by 2. So that's 275. And then the maximum was 420 on that one. And then you do the same with this set. 180 plus 250 divided by 2, 290 plus 300 divided by 2. So that one is going to be 300, and that one is going to be 215. And then the lowest here for fake is 130, and the highest is 340. All right, so if we look at both of these, let's do a uniform set. So we'll go 0, 100, 200, 300, 400, and 500. And then let's graph. So the fake, we got 130. Oops. So 130 is our low, and then 215, and then 265, and then 300, and then 340. And then for the real stuff, we are all the way down to 40. And up to 112, and 205, and 275, and 420. And so when we compare these two, it's if we're comparing how spread out they are, there's clearly a lot more variation in real cheese sodium than there is in the processed cheese. And that's probably because there is an actual process to making fake cheese. So a lot less variation in the fake cheese. In the fake stuff. All right. All right, that concludes chapter 3. We'll see you for the review.